Hi everyone. So this is day 2 of solving, what is it called? It's literally about literal equations, lesson 2. And we are on page M295. Let's use this color here. So this is our do now. This do now was technically not in your book. So we kind of just did it on this margin area. So convert to slope intercept form. And when I say that, it just literally means get the y by itself. So here we have this equation, negative 3x plus 2y is equal to 10. And all the other variables, okay, so just like x, pretend x is like a number, because guess what? It is a number. We just don't know what that number is. All right, so we're going to get rid of, again, we would get rid of the negative 3x as a whole, right? So we're adding 3x to both sides, because what is negative 3x plus 3x? 0, right? That's what we want. So that's going to be 0, because 0 plus 2y is just 2y. And then we're going to just put the x first. So 3x plus 10, because I know they're not like terms. So you can't say like 13x, because that's just 10, not 10x's, right? So it's just 3x plus 10. And I think that's the part that trips people up the most, because they're like, well, what is that? And you can't add them together. So again, they're not like terms. All right, so we're going to just treat them separately. So it's 3x plus 10. And then from here, all we need to do is get rid of that 2. And remember, when they're next to each other like that, that means they're multiplying. So the opposite of multiplying by 2 is dividing by 2. All right, so we divided by 2 on both sides here. And then I'm going to just distribute that 2. So 3 divided by 2, 3 over 2. Do not change this to decimal points. Just leaving as 3 over 2, right? X, and then plus 10 divided by 2, which is 5. All right, and that is solved for y. Happy days. Good to go. All right, and so when we're talking about literal equations, we're literally talking about like formulas, right? So in physics, you'll see this often. So if, when, no, I think you should be taking physics in high school, right? When you do take physics, you will have to solve for different variables depending on what you want, right? And it just makes your life easier later on to be able to do that. So in this case, we have this one that converts from Fahrenheit to Celsius, right? And what if we wanted to go the other way around, right? What do we do? So that's what we did here. So we're going to solve for F instead. So if you notice right here, we have this 5/9 here. And what we're going to do is we're going to cancel this out. So instead of multiplying it out, like distributing it to get rid of the parentheses, we're just going to multiply it by its reciprocal. So since the 9 is on the bottom, we'll put 9 on the top. Since 5 is on the top, we put that on the bottom. So it's 9/5. So we're multiplying both sides by 9/5. And if you notice, the fraction now cancels out. When I say cancel out, it means it equals 1, right? And because when we're multiplying, we want it to equal 1. When we're adding and subtracting, we want it to equal 0, right? That's what it means to cancel out. So the reason why we want it to equal 1 when we multiply, because what's 1 times anything? Whatever that anything is, right? So that's what we have. So we have this anything, which is f minus 32. That's all that's left. And then we have 9 over 5 times c. Now we just need to get rid of the 32. So remember, it's minus 32. So opposite of that is add 32. And obviously this 32 does not have a c there. They are not like terms, so they're separate. So f is equal to 9 over 5c plus 32. All right. And this will help us figure this out. So Josh tells Greg that the temperature where he lives is currently 77 degrees. And Greg tells Josh, so he probably lives in America. And Greg tells Josh that the temperature where he lives is currently 30 degrees Celsius, right? He probably lives everywhere else other than America, right? Because almost everywhere else uses Celsius instead of Fahrenheit. And so Josh says it's warmer where he lives, while Greg says, no, it's warmer where I live, right? So who is correct? So let's find out. And so we just plugged in 30 into this equation, into the Celsius, because for us, we understand, I don't know, at least if you've lived in America long enough, we're used to Fahrenheit. I'm used to Fahrenheit. I'm like, what is 30 degrees Celsius? I don't know what that means, right? How hot is that, or how cold is that? Because to me, it sounds really cold. So we're plugging that at 30 in here for the Celsius. And so I noticed that I'm dividing by 5, so I'm just going to cancel that out. So 30 divided by 5 is 6. So there's my 6 right there. Now I'm going to multiply 9 times 6, which is 54 plus 32. And that altogether would be 86 degrees Fahrenheit, because, That's Fahrenheit. We just found that. So what does 30 degrees Celsius mean? So 30 degrees Celsius is equal to, I shouldn't just say, I need to label that, is equal to 86 degrees Fahrenheit, right? So who's right? Greg's right. Yeah, 30 degrees Celsius is way hotter than 77 degrees. I'd rather live in the 77 as opposed to the 86, but you know, everybody has their own preference. All right, so, and that's one way to use that. And if we can skip it, you can always look over these, the same idea, right? People do it in different ways. We're gonna go right here to number 6. This is on page 97. And if you take a look here, so we have this y is equal to a times bx plus c. And we're going to solve for the variable x, all right? So we're solving for this guy right here. Let me just highlight that for you in yellow. Boom, just like that. And first thing, instead of distributing this, I'm gonna just divide both sides by a, okay? And so I divide both sides by a, and if I notice here, it's just y over a is equal to bx plus c. So notice I don't have any parentheses anymore because there's nothing outside of it. So it's unnecessary. So now I remember I'm solving for this x, so I want to get this x by itself. So here I'm going to subtract c on both sides because I got to get rid of that plus c. So how do you get rid of a plus c? Minus c. Just like if it was like, how do you get rid of a plus 5? You subtract 5. So c is, remember, just a number. We just don't know what it is. It's just a number. So in your brain, just think it's c. C is something. So plus c minus c, right? There we go. And then here, remember, we're multiplying by b, right? So the opposite of multiplying by b is divide by b, right? So we're going to divide by b on both sides. And notice right here, I already have a fraction bar, so I'm just going to put that b down there. Then here, I'm going to just divide by b there. That makes it a lot easier than trying to do fractions and fractions. Okay, which you can do, but it just gets really complicated. So we end up with getting x is equal to y over ab minus c over b. Okay, there we go. And then here we just did a random, we just did a little more practice. So we have a plus b over c is equal to d. And here we're solving for this one's, here we're solving for c. I said, oh, please solve for c. And here we're solving for a. Let me just write that down here. It says solve. So I told you guys to solve for c here, and then this one is solve for a. So how do you know which one to solve for? Whichever one you want. Okay, whichever it tells you to do, that's what you're going to solve for. So in this case, it's the exact same equation, but I'm going to solve for c here. On the other one, it says solve for a. So it's the exact same equation, but we have to do a few different steps because we're solving for a different variable. Okay, so again, like if you're in a science class and you're like, ooh, I need to find out what b is because it told me figure out b. So then we're like, okay, then I just need to solve for b. So it depends on that situation, right? But I will always tell you in class what you're solving for. Okay, I'm not going to be like solve for something, yeah, because you're like, we'll solve for what, right? That doesn't make any sense. So here we're solving for c. So if you notice right here, the c is on the bottom. You can't have it in the denominator because solving for c means it needs to be in the numerator. So what we're going to do is we're going to multiply both sides by c. And that's how we get it to the top. So we get, so the c's cancel out on the left, and we just get a plus b is equal to d times c, which is cd. I like to write these in alphabetical order just because it looks better that way. And most in general, that's just good standard practice for math stuff in general. And notice my c now is here on the right, and I need to get rid of this d. So how do I do that? Well, d is multiplying with c, so we're going to just divide both sides by d, right? And then so you get a plus b divided by d right here, and that is what our c is equal to. Boom, done. And how do you know you're done? When you get c by itself. Okay, and then here we're solving for a, right? So again, we still need to get rid of the c because we want to not have fractions, right? So because a is supposed to just be by itself, so we're going to multiply both sides by c, just like how we did for the other one. And again, we get a plus b is equal to cd. But in this case, since we want to get a, we need to get rid of this plus b. How do you get rid of a plus b? Minus b. We're subtracting b on both sides. So there's a couple different ways you can write this. So you can say, but most people will write it like this, right? A is equal to CD minus B. But you can also do negative B plus CD. It doesn't matter. It's the same thing. Okay. So as long as you have both of those things and the negative is in front of the B and not the CD, because the CD should be positive, right? Because then nowhere was it negative, right? So as long as the CD is positive and the B is negative, you're good to go. All right. And that's how you do that kind of problem. And we're going to skip a few things. Oh, we went to number 2 on the next page, which is on page 98. And we have the volume of an ice cream cone. And if you remember, the sugar cones, not the other cones, because the other cone, to find that volume is a little bit more complicated, right? It's a couple of different shapes. It's like a cylinder with like a part of a hemisphere, maybe. I'm not sure, right? We're thinking sugar cones like this. If you can see the yellow very well. Yeah, so we're looking for sugar cones there. And it says, write an equation to calculate the volume of a cone, then convert the equation to solve for the height. So here we go. So here we have the volume of a cone. The volume is equal to pi r squared times h over 3. Okay, and because basically, did you know that this top part is the volume of a cylinder? And we divide it by 3 because it takes 3 cones with the same height and the same radius to equal 1 cylinder. We're talking about volumes. So literally what we're talking about here is if I have the cylinder here, here's my cylinder. And let me just make that, this is the back part. So if it has the same radius and the same height, just like this, right? And I make this into a cone. So the volume of this cone, it takes 3 of those volumes, right? If we were to like fill it up with sand or water or whatever, to fill up that cylinder, you would need to fill it up 3 times, the cone 3 times, and dump it in to equal up a cylinder. Is that not crazy? You would think like maybe twice, but no, it's actually 3 times. What? So just a little tidbit for those of you guys who watched this video. So here we go. We have this right here. So we're solving for h. So we're gonna get rid of this fraction. So we're gonna multiply both sides by 3. So what we have left is just 3b is equal to pi r squared h. So now we're gonna just do like a 2 in 1. And so notice that the pi and the r squared are both multiplying with h. So we're just gonna do this in one shebang, right? So here we're gonna divide both of them, pi r squared, on both sides. So divide them both at the same time. So if you notice that h is all we have left is equal to 3v divided by pi r squared. All right, and that would be solving for h. All right, and we are gonna go, and the choice was between these two. All right, I'll just do this one just for fun, but it says solve for height. So we're gonna do that. And the reason why this is B1 and B2 is because they're both bases, but this is the first base and that's the second base. Because remember, if you have the trapezoid like this, right? The base is, so this is B1, this is B2, and your height is always perpendicular to your bases, right? So this is always perpendicular, but this is going to be your height. All right. And the A is obviously the area. So let's do it. So A is equal to, and again, I would please recommend that you pause this and try it yourself, because you won't know if you can do it if you're always following along with me. Okay, so try and do it by yourself. So assuming you did that, what I'm going to do here is I'm going to get rid of this 1/2 first, right? So to get rid of a 1/2, you just multiply by 2 on both sides, right? Or 2 over 1. What's 2 over 1? 2. So that's why we're just writing it like that. So 2a is equal to, now these cancel out, and we just get h times b1 plus b2. All right. Now you may think, oh, we could just distribute that, but we're not doing that because we already have h in one place. We just need to get rid of that whole thing. And what is b1 plus b2 doing with h? They're multiplying, right? What we're going to do is we're going to divide by b1 plus b2. And so if you were in class and you saw this go down, people chose 4 because they thought it was simpler. when in fact, this is actually way simpler, like way simpler. So here, these cancel out and we just get h is equal to 2a over b1 plus b2. Done. So the height is equal to 2 times the area divided by the sum of the two bases. I know, crazy, right? Who would have figured that one out? All right, and then so this one, right, so you see how this is way more complicated? What? All right, so we did exactly the same thing, except here we got rid of the fractions, and on the right we did not get rid of the fractions. All right, so it's the same thing. So again, here we want to solve for a. So a is our guy right here. If you notice that, so the denominator is b and d, right? So they're two different numbers. We don't know what they are, so we don't know. So basically, we're just going to multiply both sides by bd. Okay, and so this is on the left-hand side is going to be bdz. So b times d times z right there is equal to, here's my a that I want, right? So now notice the b is on the denominator here, so the b's are going to cancel out, but we still have d left. So it's going to be a times d right here, plus, now in this fraction, the d's are going to cancel out, and all we have left is a b. So it's going to be bc. All right. So again, now I want a by itself, so I've got to get rid of this bc, the adding stuff, right? So how do we get rid of an add bc? Minus bc. So there we have that. And then, okay, these are obviously not like terms because the variables are not exactly the same. So therefore, it's just going to be bdz minus bc is equal to ad. And again, we want just the a. So we're almost there. How do we get rid of this d? Remember the a and the d are multiplying. So we're going to do the opposite of multiplying by d, which is divide by d. So we divide both sides by d and we get bdz minus bc divided by d. Right? It's like that. So we did the same thing over here, but instead of getting rid of fractions, we just dealt with them. All right. And so if again, our a is right here. And so we're going to get rid of the pluses stuff. So we're going to subtract c over d on both sides. Right. And then we get z minus c over d because they are not like terms. Can't add them together. And then here we get just, so the c over d's cancel out. And then we just get a over b. And now we're close because we want a by itself. So what do we do? Multiply both sides by b. So you get bz minus bc over d. Okay, because we're going to distribute that b. Right? So you may have been wondering, we're like, Miss Lee, these are not the same thing. Like, can you do that? Right? And if you notice, they are actually the same thing, except this is written with one common denominator and this one is not. But if we were to make them same denominators, I would just, because the common denominator is d, so this is just going to be d over d, right? This is dbz, or same thing as bbdz. Remember, multiplying order does not matter, right? And then I would just write that as one common fraction, which is going to be bdz minus bc over d. So that was, and so if you notice right here, it's the exact same thing, right? So, but you don't have to write it that way. You can just leave it as bz minus bc over d. That's fine. Either way is okay. And then for the second one, if you notice right here, this was our d. Again, I know these are trippy, but if you can just think in your brain that these are just numbers. They're just numbers. It'll make life a little bit easier. All right, so again, here we're solving for d. So let me get solving for this guy right here. So again, they're still on the bottom, and we don't want it on the bottom. So let's just do what we did before. We're going to multiply both sides by bd. Okay. If we multiply both sides by bd, what do we have? Again, the same thing. So bdz is equal to ad plus bc. All right. And again, but here's the problem. We have d's on both sides of the equation, right? So think back to what we did when we had x's on both sides of the equation. What do? We get them together, right? So that's what we did. So we're going to be like, okay, well then let's subtract ad on both sides. So now we have bdz minus ad. We still have the same problem. We still have two d's, but at least they're on the same side now. Okay, they're on the same side. So what we're going to do is we're going to actually factor out that D. Okay, because since they both have D's in common, you can factor that out. So here I have my D out here. What do I have left? Just BZ minus this A. All right, is equal to BC. And then, so now if you notice right here, do you see how what we did here? This whole BZ minus A, that is multiplying with D. So what we're going to do is just divide both sides by that, right? So what we get is D is equal to BZ, BC over BZ minus A. What? I know, but I would definitely take the time to practice it. Your homework is this part right here, number 3. So practice those ones. The answers are given to you down below. If you have any questions about it, you're like, Miss Lee, I tried to solve it for whatever the variable was. I can't figure it out. Just take a picture of your work and send it to me, and I will look at it and send an email back to you. Right? I'll see you later. Bye.